In this notebook, I'm going to go over an implementation of style transfer following the details outlined in this paper, Image Style Transfer using Convolutional Neural Networks. We're going to use a pre-trained VGG 19 net as a feature extractor. We can put individual images through this network, then at specific layers get the output and calculate the content and style representations for an image. Basically, style transfer aims to create a new target image that tries to match the content of a given content image and the style of a given style image. And here's our example of a cat and a Hokusai wave image as an example. But with the code in this notebook, which is in our public GitHub, you'll be able to upload images of your own and really customize your own target image. Okay, so first things first, I'm loading in our usual libraries, including a new one, the PIL image library. This will help me load in any kind of image I want to. Next, I want to load in the pre-trained VGG 19 network that this implementation relies on. Using PyTorch's models, I can load this network in by name and ask for it to be pre-trained. And I actually just want to load in all the convolutional and pooling layers, which in this case are named features. And this is unique to the VGG network. You may remember doing something similar in the transfer learning lesson. We load in a model and we freeze any weights or parameters that we don't want to change. So I'm saving this pre-trained model, then for every weight in this network, I'm setting requires grad to false. This means that none of these weights will change. So now VGG becomes a kind of fixed feature extractor, which is just what we want for getting content and style features later. Next, I'm going to check if a GPU device is available, and if it is, I'm moving my model to it. And I do recommend running this example on a GPU just to speed up the target image creation process. Then this is going to print out the VGG model and all its layers. We can see this sequence of layers is all numbered. Here's the first convolutional layer in the first stack, conv11, and its number 0. We have the second in that first stack, conv12, and its label 2. Then we have a max pooling layer and conv21 in our second stack. And we can keep going until the very last max pooling layer. Next, I'm going to continue loading in the resources I need to implement style transfer. So I have my trained VGG model, and now I need to load in my content and style images. Here I have a function which is going to transform any image into a normalized tensor. This will deal with JPEGs or PNGs, and it will make sure that the size is reasonable for our purposes. And then I'm going to actually load in style and content images from my images directory. I'm also reshaping my style image into the same shape as the content image. This reshaping step is just going to make the math nicely line up later on. Then here I also have a function to help me convert a normalized tensor image back into a NumPy image for display, and I can show you the images that I chose. I chose an octopus for my content image and a David Hockney painting for my style image. I really like to do people or animals for content images and bright artistic paintings for style images, but it's really going to be up to you in this case. Okay, so now we have all the elements we need for style transfer, and next I'm going to give you your first task. We know that we have to eventually pass our content and style images through our VGG network and extract content and style features from particular layers. So your job is going to be to complete this getFeatures function. This function takes in an image and returns the outputs from layers that correspond to our content and style representations. This is going to be a list of features that are taken at particular layers in our VGG 19 model. And this function is almost complete. It just needs a descriptive dictionary that maps our VGG 19 layers that are currently numbered 0 through 36 into names like conv11, conv21, and so on. And I've given you the first layer that we're interested in to start. If you need a reminder for which layers make up the content and style representations of an image, take a look at the original paper and identify which layers we'll need. Then list them all here. And if you get stuck or don't know where to start, I'll show you my solution in the next video.